What is the Maunder Minimum? Have you ever wondered how changes in solar activity can impact our planet's climate? One fascinating period to consider is the Maunder Minimum. This was a time of very low solar activity that lasted from around 1650 to 1715. During these years, the sun produced fewer sunspots and emitted less solar energy. This drop in solar output had a ripple effect on Earth's climate and weather patterns. The Maunder Minimum is often linked to the Little Ice Age, a time when global temperatures were generally cooler. This Little Ice Age lasted from about 1440 to 1920. In the polar regions, the effects of the Maunder Minimum were particularly noticeable. The reduced solar energy, especially in ultraviolet light, impacted the formation of ozone in the stratosphere. With less ozone, atmospheric circulation patterns changed. One key player in this was the North Atlantic Oscillation. This oscillation affects the balance between high and low pressure systems near Greenland. During the Maunder Minimum, when the North Atlantic Oscillation was in a negative phase, winter storms often shifted eastward toward Europe. This resulted in colder winters across the continent. These changes in atmospheric circulation also influenced the polar regions. Variations in temperature and precipitation patterns were observed. For example, the polar regions experienced shifts in their climate, which could affect ice cover and ecosystems. The cooler temperatures during this time meant that the polar ice caps were likely more extensive than they are today. Understanding the Maunder Minimum helps scientists analyze past climate variability. By studying this historical event, researchers can make better predictions about future climate changes. The polar regions are particularly sensitive to these changes, and knowing how past events influence them can inform our understanding of current trends. In summary, the Maunder Minimum was a significant period of low solar activity that affected climate and weather patterns, especially in the polar regions. By looking back at this time, we can gain a clearer picture of how solar activity interacts with Earth's climate system. This knowledge is essential for predicting how our planet's climate may evolve in the future.